Hi everybody, DK here with Mr. B Amps, and today on our Amplifiers for Rookies series, part 2, we're going to talk about Class A versus Class AB. What the heck that even means? Well, for those of you with a little bit of amplifier knowledge, everybody kind of accepts in the guitar world that a Class A amplifier has one power tube, and a Class AB amplifier has 2 or 4 power tubes, or maybe 6, and are louder and more powerful. Well, I challenge that notion to a degree. Our Braddock amplifier, which is the black amplifier there, the thing on top is not an amplifier. Well, kind of it is, but it's a spring reverb device. So the black amplifier there, which is a Class A amplifier, I will tell you can rival and nearly equal the volume of both of our push-pull amplifiers here, the Red Smokin' Joe and the Seafoam Grain Monarch. So there you go. But we'll talk a little bit about why and what actually makes an amplifier Class A or Class AB or even Class B. You ever heard of a Class B amplifier? Maybe there's a reason why. So let's actually try to simplify that and make it as logical as possible for the uninitiated electronic super nerds who aren't super nerds. I sound like a politician without a teleprompter. Okay, much blessing and honor go to those who have attempted to explain this topic before me. Understanding something and being able to explain it to somebody who may not understand it are completely different things. So let's start with a Class A amplifier and a few basic concepts that we have to understand. Okay? In a wire, just an ordinary piece of wire, like that, I can have both alternating and direct current at the same time. Okay? When we think of direct current, we think of batteries. The current will simply flow in one direction all the way there, right? Alternating current, the current will go back and forth. And of course, we like to draw that on our little scope with, below 0 volts, above 0 volts, below 0 volts, above 0 volts. But what if we, for example, let's go with very, very easy numbers. If I have 1 volt DC on this wire, 1 volt DC, okay? And I put 1 volt peak to peak AC on this, right? Or actually, no. Let's go with 2 volts peak to peak. So 2 volts peak to peak. I have 2 volts. That's peak to peak. So peak to peak means we go up 1 volt, down 1 volt. Okay. So you with me? We're going to go down 1 volt, up 1 volt. So I have 1 volt DC here. 1 volt. Volt is electromotive force, by the way. In Ohm's law, it was originally E equals I times R, not V equals I times R. E is electromotive force. Voltage is a force. Okay. Think. Focus. 1 volt DC with the positive over here, meaning current wants to run to the positive. Flows from negative to positive, so positive is the magnet. 1 volt peak to peak. On our up cycle, we would actually see 2 volts, come back down to 1 volt, go all the way to 0 volts, go back up to 1 volt, up to 2, back to 1, down to 0. Okay? So essentially all we did was take the 0 mark and scoot it up in the entire waveform, so this AC line would travel up there with it, just by going up 1 volt overall. So we can have DC and AC on a line at the same time. Okay. Does that make any sense at all? I hope so. If it didn't, you can tell me what an airhead I am in the comments. Okay. So in amplifier circuits, we always talk about B+. As a complete and total noob wanting to build an amp, everybody's talking about B plus this, B plus that. What the heck is a B plus? Well, it's an old term. B plus being battery plus. Well, it's not a battery. But I guess in really old radios it was a battery. Like really, really, really old batteries, it was a radio. B plus is positive DC voltage. That's all it is. Your positive DC voltage. And in this case, ground is going to be your 0 point. That's going to be your 0 volts. Maximum DC volts, 0 volts. Cool? Okay. Now, in your standard tube amplifier, pretty much any of them, you will have an output transformer. They draw it like this, right? The one transformer concept that we want to get through. I can put DC through one side of the transformer and it will go through, right? One side. So if I put it in here, it'll show up here, right? But transformers can only pass AC across to the other side. Okay? So, if there is AC here, back and forth, there will appear AC on this side. See this thing marked load? That's your speaker. That's your speaker over there, making music. So if I put a audio signal, alternating current over here, it will pass to the other side of the transformer and come out the speaker. That's actually kind of what they're showing here. Get a smaller signal in, and it goes through the tube, and up there, passes through the transformer and comes out louder. Good with that so far? Okay. Now, with vacuum tubes, we have all types. We have triodes, tetrodes, which we generally don't use, pentodes, beam tetrodes, and I think there's even heptodes. Yeah. Generally what we use in tube amps are triodes, penodes, and beam tetrodes. But we don't care, okay? We're not even going to care. We're only going to treat everything kind of like it's a triode, because that makes the most sense. Current, electrical energy through a tube, always wants to go from ground to positive voltage. Always to positive voltage. Okay? So, positive voltage always wants to go this way through the tube. Okay? Now, if we're going to have an audio signal, when we look at an audio signal on our scope here, or on our little drawing, our audio in, we have 0 minus some volts plus some volts, 0 minus 0 plus, so it's going up and down. It's passing the 0 point. That's kind of like the signal out of your guitar. It has pluses and minuses, right? But thank you, whoever drew this, that the signal coming out, the midpoint, includes the DC. Okay? In order to get anything through this tube to actually work, we have to apply positive voltage to the plate or anode. Okay? We put voltage to the plate or anode through our output transformer, and all of a sudden a ton of current is going to want to go through here, turn our vacuum tube bright red, and burn it up. Great. All the energy comes through the cathode wanting to get to the anode. But we refer to tubes in some other countries or vernaculars as valves. And they really do work a lot like valves. On your tube, you have what is called a grid or a control grid. Control grid is a good name for it. It's sort of like the on-off valve part of a hose bib, like where you can turn your garden hose on or off. By applying a negative voltage to this tube, you can effectively turn it off more or on more just by what you put to there. So it would be possible for me to apply a negative voltage and actually shut this tube off, so it would not conduct any current from the cathode up through the anode. We could turn it off. That doesn't make any sense though. We want to amplify, right? So I've got a ton of energy here. If I could just harness it and release it at the same rate as my input audio signal, I apply a little bit of positive voltage and I get a big positive voltage. I apply a little bit of negative voltage and, well, wait a minute. The energy on this tube is only supposed to go that way. How can I get a minus out of this? Well, that's a thing we call bias. It's essentially setting the midpoint of the tube, so it can go up or it can go down. Because by default, the tube only really wants to conduct that way, right? It only goes that way. But if it's already running this way, but we just slow it down, okay? We just slow it down. Now we can have a rise above our idle current, or what we've set our bias at, and we can have less than. So we have a greater than and a less than when we put a signal in here. Does this make any sense? Are you guys getting this? So biasing the tube is essentially, in a Class A amplifier, is equivalent to sort of turning it off halfway, establishing a midpoint. Okay? Now a bunch of that audio signal is just, you know, flying away through here, but as we have all of this B+, it's going to be probably 300 volts up here of B+. We got 300, but we have 300, say, plus 20, back to 300. It'd be 280 because it'd be 300 minus 20, right? 300, 320, 300, 280, 300. So we do have an alternating signal, which will pass through our output transformer and amplified and become, you know, this is essentially an amplified signal that will feed our speaker. Okay, is that cool? We getting that a little bit? Okay. I think we're getting it. I hope we're getting it. I know what I'm doing, I swear I do. Okay, so there are two ways we can create a bias in this tube. We can do it from the control grid by applying negative voltage, like minus 20 volts, minus 30 volts, minus 40 volts. It depends on what tube it is as to what that is. But by applying negative volts here, I can effectively turn this tube off. Not really common in Class A amps, but using a resistor on the cathode. Essentially, I'm putting the brakes. The resistor is putting the brakes on the crazy amount of current that wants to go through here, thus creating a new midpoint. Okay? Okay. So we have a tube and we have a line. This line is sort of going to represent that midpoint that this tube can handle. Okay? By default, a 6L6GC such as this is capable of dissipating up to 30 watts of power. So we need to know what the head to tail voltage is, the plate to cathode voltage. What the voltage from here to here is. Okay? And we can measure that. And based on what that is, we want to calculate, since this is a Class A amplifier, roughly somewhere between 80 and 90% of that 30 watts. We don't want to hit that. So in the event that we had 360 volts from cathode to anode, you want to go for 75 milliamps. I know we're getting technical. If we bias a tube too hot, it essentially will overheat and fail. And my clock is reminding me how this lecture is going. If we bias a tube too cold, meaning we put too big of a resistor on here and reduce so there's not enough current flowing through here, well, the tube certainly isn't going to burn up, but it isn't really going to be very loud. It's not going to be effective. Okay? So the whole entire point of biasing a tube is to set it, because by default it wants to flow as much energy as absolutely possible right through that tube, which will burn it up. But by biasing it, we're backing it down. We're backing it down so we can go above and below. We're finding a nice happy midpoint where this tube is being used to its full potential without roasting it. Cool? Okay. Now you can go watch something fun for a minute. Go watch the amp tech for Angus Young's AC/DC. He was speaking about how they bias the amps extra hot because Angus wants to listen to it while they bias it, so they bias it by sound, and they go through a lot of tubes. If you bias a tube hotter, you will get more power out of it, for sure, but you will shorten the life. But if you underbias it, it will sound weak. So on our tube guide here that we were looking at, the 6L6GC is capable of 30 watts at idle. Oops, I accidentally clicked the thing. It's capable of, great, I picked a completely different tube. But it's capable of up to 30 watts, so you're going to want to bias it for close to that. They recommend 90% is your maximum. So you would want to go to 80 to 90% of the tube's capability for Class A. Don't go over 90 or your tube's going to die. Okay, now what's a Class B amp? Wait a minute, we don't use Class B amps, do we? Do we? Maybe. They exist. Okay, so what is a Class B amplifier? Well, as you know, when we looked at the Class A amplifier, it's always flowing current, and that makes it kind of inefficient. They're not really that loud, and there's always some energy going through the tube even when it's not making any sound, right? Because you always got current going between here, right? You got your right in the middle of the signal, so you're wasting energy. In fact, just for kicks and giggles, let's prove my point. Here's the back of an Epiphone Valve Junior. Now mind you, it has 2 tubes in there for a total of about 5 watts of output power on a good day with the wind blowing right. Both of the tubes are biased to Class A. One of them's a preamp tube, they don't use much. And then we have the power amp tube, which is a 6BQ5 or EL84. That can produce up to 5 watts of audio power. Yet the power consumption is 35 watts. That poor little beast is wasting a lot of energy. For shame. Okay, now recall how we talked earlier. If you put enough negative voltage here on a tube, you can effectively turn it off, right? So it just kind of stops flowing current. Well, that's a lot less wasted energy, isn't it? Well, sure, you turned the valve off. Cool. So what if we could put... This is an output transformer for a push-pull type circuit. And as you can see, I oriented the tubes. We have anodes on each side. And one can pull and one can push. That sounds great. And we'll bias these tubes so when there's no audio going in and there's no reason to push or pull, there will be no current flow. I have developed a very efficient amplifier. Well, pretty efficient. Class B is kind of the most efficient thing they tried as an audio amp. But how many Class B audio amplifiers do you see out there? The answer would be 0. And there's a simple problem. Tubes are not instantaneous, nor are transistors. So if you want to turn on one tube to create a positive, and you want to create the positive part of the wave, and you want to turn the other tube on for the negative part of the wave, right? Turn one on, turn the other one off, right? And you're turning one tube off on every side. So on the high side of the cycle, this tube would be on the low side, this would be on. Following me? Here's just a wave. Upper part of the wave, this tube's on. Lower part of the wave, that tube's on. And of course during the lower part of the wave, this tube is off, that one's on. Then we go back positive again. This one's on, that one's off. Sounds great, right? Well, valves aren't that fast. They're not fast enough. And you end up with a problem called crossover distortion. This is actually a drawing for transistors, but the same thing happens in tubes. When trying to switch from one to the next, there's this brief period of offness, and it ends up with this ugly, horrible sounding hiccup in your audio signal. So that's why we do not use Class B amplifiers for guitar amps. We use Class AB. Yay! So I was hiding the rest of my drawing here. In a Class AB amp, if we were to use our general line here, being in a Class B amp, we would have one tube that would conduct only on the positive side and one tube that would only conduct on the negative side, right? In a Class A amp, we would have a tube that conducts on both the positive and the negative sides, hopefully somewhere in between, right? So what would we do in a Class AB amp? Well, it's kind of somewhere in between. One tube will conduct, actually when the signal is small enough, when you are playing it at moderate volumes, both tubes will work together. The wave will not necessarily exceed the amplification of either tube. However, if it gets loud enough, you will get to a point where one tube will turn off and the other will take over. Because they are working together in the middle of the wave, you avoid that crossover mess, because both tubes are on for probably a good percentage of the cycle. Both tubes are working together. It's not till you get to the extreme peaks that only one tube is working. By using the two tubes together, you gain great efficiency. This is a Class AB amplifier. On the picture we have here, it actually shows the signals for each tube, which, remember, one's pushing and one's pulling. So on smaller output, both are active all the time. So this one we have, you know, down, up, coming, that's that tube, right? So, and then that's this tube working on this lead, which of course they're going to be opposite waveforms because they're pulling in opposite directions, push-pull, right? Okay? But when you get to large extreme volumes, the top tube will turn off when the bottom tube is finishing the wave, and the bottom tube will turn off when the top tube is finishing the wave. So only when you get extra loud does that happen. Is that cool? Does that explain what a Class AB is? You get it? Do you get it? A little? Class ABs are significantly more efficient than Class A's. You do get a lot more power. So let's just take a 6V6 tube, for example. It's extremely popular as a single-ended tube, right? We have that infamous Fender Champ, and there's silver tones, and there's amplifiers galore. For anybody who's ever owned one of those amplifiers, what is generally the power rating, or the rated power, audio power, out for a single 6V6? Ding, 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 ding. Generally they're rated at about 5 watts, right? Okay. Now, amplifiers with two 6V6s in Class AB push-pull are also really common. In fact, that's what the Monarch is over there, our Seafoam Grain Monarch amp. That's what that is. That one's rated for 14 or 15 watts. Got quite a few amps here that are 14 or 15, and you can even push these even to give you like 18 in push-pull. Depends how close you're pushing them into Class B. Okay? Follow me here. If I'm going to wire these up push-pull, and I like to flip them over for visual sake. In lower volumes, they're obviously both conducting. But the farther out I bias and adjust them, which this is all done via the circuit, the higher maximum plus I can get, and the higher maximum minus I can get. There's a lot of trickery in this. So you may see an amplifier with two 6V6s where one is rated for 14 watts, one is rated for 18 watts. And it doesn't necessarily mean that one is lying, even though they use the same tubes. They may just be using them a little differently. Cool? Okay. I think that's enough. I think my brain hurts, and I think your brain hurts. But, wait a minute. I told you earlier that the Braddock amplifier over there was a single-ended amplifier, but could still manage to keep pace with the Red Smoke and Joe amp and the Monarch amp. The Monarch uses two 6V6s in Class AB to produce 14 or 15 watts. The Smokin' Joe uses two 6BQ5 or EL84 if you wish to produce about 15 watts push-pull. So how the world is the Braddock amp able to get that kind of volume level and still be single-ended? For those of you who have seen the old really horrible video of the Braddock, maybe you already know. Unlike typical normal Class A amplifiers that use something like a 6BQ5 or a 6V6, this amplifier uses an 807 tube commonly associated with radios. This thing is huge. This nice beefy tube here can produce up to 12 watts of sound. It's quite a beast, but there are some trade-offs. Remember how we talked about Class A amps being electrically inefficient? Yeah, this amp's a power hog. And as a result of all of that current that has to flow through that output transformer, the output transformer has to be big and beefy, meaning this amp weighs more. This amp weighs probably 20% more than the Red Smokin' Joe over there. And the Red Smokin' Joe technically is a little more powerful. But this one's Class A, and it makes me feel cool. Some people just really love the sound of Class A amplifiers, and that's cool. Some people like the sound of Class AB amplifiers, and that's cool too. Class A amplifiers are sort of notable for being a little warmer, maybe a little fuzzier, maybe a little less crystal clear, but having a really cool response and, you know, just a good feel to them. Where Class AB amplifiers have the more clean, sparkly, hi-fi kind of thing. Whatever's your thing, play it. But hopefully now when some amplifier nerd comes up and starts talking about whether things are Class A or Class AB or whatever, now at least you'll know what they're talking about. And if you have no idea what I talked about in this video at all and you're still completely clueless, please tell me in the comments section. Thanks for watching. Have a great day.